We're going to talk about graphing logarithmic functions, and what you need to remember is that a logarithmic function is an inverse of an exponential function. And so if we compare the graphs of these two functions, an exponential function, if it looks like this, a logarithmic function is going to be reflected over the line y equals x. Oh, my pen's going crazy. And it will end up looking something like this if it's reflected. Now there's going to be three key points that we want to look for when we're graphing a logarithmic function. The first one is whatever is going to make our power equal to 1. Remember, our power can't be equal to 0, but 1 is a very pretty thing, because if our power, or in this case x, equals 1, that means that our exponent was equal to 0. So in our parent function we would have the point 1, 0. The next thing we want to look at is what if our base, I think it stopped recording. No, it didn't. The next pretty ordered pair that we want to find is what if our power is simply the same as our base. And so in this case, what if you said x equals b? Well, in that case, that's one of our properties of logarithms, because we'd have a log base b of b, and that's just equal to 1. Now the last point is a little bit weird, because we're actually going to look at the y value first. And if we plug in -1 for our y value, that means in this case we would have b to the -1 when we change this to exponential form, and we'd have 1 over b. And these 3 points will give you the basic shape of a logarithmic function. So let's look at this logarithmic function now. And so we have log base 3 of x. And so the first thing we want to look at is what if x is equal to 1? Well, in that case, that means our exponent is equal to 0. And so we'll plot the point 1, 0 first. Next thing we want to look at is what if our base has what if our power is the same as our base? So if x equals 3, that means that y is equal to 1, because we'd have a log base 3 of 3. Next thing we want to look at is what if we plug in -1 for y? So we basically have -1 equals log base 3 of x, and that gives us 3 to the -1 equals x, and that's just 1/3. So these 3 points give us our basic shape of our function. And in logarithmic functions, we have a vertical asymptote, whereas in exponential functions, we always have a horizontal asymptote. In this case, our vertical asymptote is the line x equals 0. So we look at translations or transformations of logarithmic functions, and the same thing is happening with these as has happened to all of our other basic functions that we've talked about. If we have plus k out here, that's going to be a vertical translation up or down. Minus h, that's going to give us our horizontal translation left and right, and a is going to stretch it or shrink it. So let's look at 1/4 times log base 4 of x minus 3. Well, we know it's going to be shifted down 3 units. And then the 1/4 is showing us that we're shrinking it vertically. But let's go ahead and work on finding those 3 basic ordered pairs. So let's look at first, if x equals 1, what is happening? And so in the case where x equals 1, we're going to plug this into the equation and see what happens. So we would have y equals 1/4 times log base 4 of 1 minus 3. And we're going to solve this for y. If we add 3 to both sides, and you'll see why I'm doing this in just a second. We add 3 to both sides, we get y plus 3 equals 1/4 times log base 4 of 1. Let's multiply by 4. So we get 4y plus 12 equals log base 4 of 1. Now when we change this into exponential form, we get 4 raised to the 4y plus 12 power equals 1. Well, in this case, 4y plus 12 needs to equal 0. And when you solve that, you get y equals -3. So our basic start point is right here, and that's what's happening. That k value shifted this downwards. Now let's look at what happens when we make x equal to 4. And this one's a lot easier to solve, because in this case we have y equals 1/4. Log base 4 of 4 is just going to be 1 minus 3. So we have 1/4 minus 3 is going to be -2 3/4. And let's look at what's happening with the shape of our graph so far. So we have 4 and -2 3/4. And because we don't have any shift here where our power is, our vertical asymptote is still going to be x equals 0. Now if we wanted to find that final point where y equals -1 and then go through and solve for x, we could. But let's just go with what we have. This is much flatter because it's a vertical shrink when we put that 1/4 in front of it. And so this is going to be the logarithmic form in this case. And those 2 points gave us pretty good shape. This showed us that we didn't have any change in our vertical asymptote, and this -3 shifted our original one down 3 units. So 2 times log base 1/2 to the x minus 1 power. So in this case, let's look at what happens when we make that power equal to 1. And so in order to do that, we're going to have to plug in 2 for x. And so when we plug in x equals 2, we get f of 2 equals 2 log base 1/2 of 1. So that's basically y equals that. So we're going to do the same thing that we did last problem. And we're going to do y divided by 2 to get that log isolated. And now we're going to change this into exponential form. So we have 1/2 to the y divided by 2 exponent equals 1. So in this case, y divided by 2 needs to equal 0. So y is going to equal 0. So the next thing we want to look at is what's going to make this power be the same as the base. So x minus 1, what value of x is going to make that equal to 1/2? And that's going to be 3/2. So if I plug in 3/2 for x, we get y equals 2 times log base 1/2 to the 1/2. Well, this part of it equals 1, and so we just have 2 times 1, which is just 2. So we have 3/2, 1 1/2, 2. So this one is a little bit more tedious, but because that base is between 0 and 1, makes the shape of this change a bit. So now we're just going to plug in where y equals -1. So we're going to plug in our output value and say -1 equals 2 times log base 1/2 to x minus 1. Now I'm going to change this into exponential form pretty quickly. I'm first going to use this property of exponents and change that to x minus 1 squared. Now, moving this to exponential form, so we have our base is 1/2, our exponent is -1, and our power is x minus 1 quantity squared. Well, 1/2 to the -1 power is 2. So we get 2 equals x minus 1 squared. Square root both sides, and we get the square root of 2 equals x minus 1. and that's going to give us 1.41 for the square root of 2. So x is going to equal 2.41. So we're going to go to 2.41, negative 1. Now our asymptote is no longer at x equals 0 because this function has shifted because of this minus 1 here, and it shifted to the right one. So our asymptote is now at x equals 1, and we have the basic shape of our function, and so it's going to hug that asymptote as it comes down and continues this way. So that's it on graphing. The only other thing that I wanted to look at was this final slide here. And this is actually, I think you can follow this work pretty well, so I'm going to leave it at that. Thank you.